Hello everyone, reporting today for Fun Robotics Network. I'm Abhas, and with me here is Team 23213 Open Source from Willis, Texas. They were just recently the winning alliance captain at the Houston Regional Championship, earning them a spot at the Houston World Championship later in April. They have one of the most efficient robots I've seen this season. They're currently ranked 5th in auto, 25th in teleop, just really, really awesome driving, and I think teams have a lot to learn about their efficiency and optimizations coming up on Behind the Bot. All right, Open Source. So one thing that's always stuck out to me about your guys' design is just how wide your robot is. I mean, clearly you guys have good design skills. You could make it more compact if you wanted. So what was, like, why did you go for such a wide design?
Yeah, so we made this chassis actually last year, and it's modular, so that allows us to kind of use it year to year. So for the wide design, we're just able to say, hey, this is the chassis we have, and we're able to use this and get it down faster. And we also just looked at it and we said, this arm fits well here with this size.
Okay, yeah, so, just so you can hit the ground running. With that, I know like a lot of teams have switched to new odometry systems like just this year. So since you were reusing your chassis from last year, did you have to update it? Did you stick with the same odometry? What was that like?
So on our robot, last year we had custom pods that didn't work very well, and then we switched to the then new Go Builda dead wheels, but now we have the new 4-bar Go Builda dead wheels, and we switched from rubber to Pedro pathing this year.
Okay.
And now we use pinpoint with those dead wheels.
Yeah, that makes a ton of sense. Now, kind of jumping into the pivoting arm architecture, why that specifically?
Yeah, so we kind of looked at it and we realized that one, that'll allow us to both do the hang as well, because we have a 278-to-1 ratio on it. And then for the pivot arm specifically, we looked at the geometry, and when we hit the front of our robot, our arm is able to go ahead, and when it hits the bar, it goes straight on to the scoring position.
Okay, I see. And yeah, one more question there with that almost 300-to-1 ratio. How are you achieving that? Like, is it just multiple gear stages? What do you have going on there?
Yeah, so we have 2 Go Builda motors here, and then you can see the bevel gear sets as well.
Okay, great. So it's just a very high ratio motor and then a bevel gear.
Yes.
Okay, got it, makes sense. Okay, now jumping into your claw, you guys have one of the fastest intakes this season. It seems like you're just in the submersible zone for a fraction of a second. What do you think were like the biggest features on your claw that enable this speed?
Yeah, so we knew we wanted a single point of contact for both our intake and output. So we kind of optimized that by putting 2 servos and then having 2 Gecko wheels from Go Builda. And that just allows us to immediately suck it up. And then also we have a limit switch in here. That way it's not up to the driver. It triggers when the part gets into the gripper.
And so with that limit switch, I guess, is that something you've had like just from day one of the season, or it was like you played a couple meets and then you were like, no, we really need this? How did that look?
So, like you said, that is something we did have since the start, because we decided that it was already pretty hard for us to see into the submersible. So we wanted to find a way to utilize something to where it could automatically see if we have a part instead of us having to decide once it's intake.
I see. And so, yeah, also with that limit switch, you don't get the color feedback. Is that something that's been a problem for you guys, or just not really?
No.
Okay.
I think our gripper is more precision, so that wasn't really an issue.
Yeah. Okay, got it. Makes sense. And last question there, I noticed with the axons, you're running them geared or chained to those Gecko wheels. Was that just so you could up the speed ratio? Was it more of a packaging thing? What was going on there?
It was more of a packaging thing. So we originally had it designed to where they were kind of sticking out the back, and that was also with the chains. But when we got the flipper grip, we had to make sure that it was as compact and light as possible. And gears are...
And yeah, while we're already there, let's talk about that flipper grip, as you called it. Walk me through what that mechanism is.
Yeah, so flipper grip, it's a pass-through system. And this basically allows us to score and grab from the back of our robot. And that just made our cycle times a lot faster. So how this works is we have 2 servos here around this pivot point, and that just controls the up and down. And then we also built in another servo here, which controls our wrist movement. And then we wanted it all at the back to make sure it was light as possible, along with we put in carbon fiber to make sure it was light. That way we're not putting any strain or stress on those servos.
Cool, yeah. And it seems like you guys have like pretty much every different material an FTC team uses on your robot. So, walk me through that, like how you guys decide which materials to use, and any other places you had to make like a really important decision, as you said with the carbon fiber there.
Yeah, so as I mentioned, like the carbon fiber we knew we wanted it to be light and strong. As for like all the 3D printed parts, that's really just, it's the cheapest, we can access it easily. So like if I design something in CAD, I can quickly get it prototyped so that we can work on it faster. For the metal, that's just to make sure like in those high stress areas, it's not breaking or anything. And along with it's easier to do than the carbon fiber. So we don't have as much of it.
Cool, yeah, and looking towards the World Championship, now that you do have some time, do you envision replacing a lot of the components on your robot with carbon fiber, or you're kind of just going to keep it how it is because it works?
I think we'll keep it how it is. We're really looking forward to making new improvements instead of changing what we already have.
Cool. And talking a little bit about your specimen cycles, they are extremely, extremely fast. What do you think are like 2 or 3 of the really key features that enable this speed?
So I think mainly the way we achieve this speed is because of the way it was designed as well as the sensors we implement. So with the flipper grip, once we change to this, we're able to basically just run into the wall, and it hits this limit switch here and it triggers it to go this way. And then once we get to the submersible, it hits these touch sensors right here and it automatically scores it. So everything is basically happening with minimal button presses, and we're just driving forward and backward instead of pressing a lot of buttons.
That's really cool. So are your specimen cycles entirely automated, mostly automated? Walk me through that.
So everything that's not automated is the chassis driving, and after we score one, there's a button press to bring it back to grab another one. But other than that, it's completely...
Okay, cool. And, talking about samples as well, are there any automations you use there that are different from the specimens?
So with samples, again, we use the limit switch to pick them up, and then we use PIDs in both our slides and our arm to bring it up to the bucket when we score.
And for your slides, are those powered by motors that are on the pivot itself, or are those motors mounted, like fixed to the robot chassis?
Yeah, so it's on the pivot here, and it's just connected to these 2 GoBuilder rails that we connected via some 3D prints. But yeah, it's just a motor with a beveled gear set.
Okay, awesome. So that's single motor then, right?
Yes.
Okay, so we're looking at 7 motors total for the robot, is that correct?
Yes.
Okay, awesome. Now, looking towards your hang, you guys also have a very quick hang mechanism, and it seems to have a lot of really cool features to be that fast. Can you describe what you have there?
I'm going to be completely honest, our hang is actually really simple. So it's based off of that ratio that I mentioned earlier, the 278:1. But the actual hooks themselves, they're spring powered with rubber bands. So you can kind of see here's one of our rubber bands. And then it basically just locks onto the bar, so it kind of like hits, and then once we get past a certain point, it'll click in place.
Okay, and what's going on with the tape there? Was that like a last minute addition, or was that something intentional?
It's kind of just for grip.
Okay, very cool. And I think the last thing I want to touch on is your guys' driver practice and game strategy as a whole. I feel like I see you guys posting a ton of scrimmage videos and practice videos with teams. Walk me through your process behind that.
Yeah, so we like to meet with as many teams as possible. We're not really very secretive. We want to try to get strategy and kind of build up the first community. So we've hosted like a couple of scrimmages. We have open Fridays. So like if anyone wants to come play with us, we're totally down for them coming with us. And that's also our strategy is to be the best alliance partner. So we kind of focused on taking the harder task, which this year was specimens, but kind of just depends. We just want to be a good partner.
Okay, yeah, and what do you think are some of like the biggest takeaways you've had from these scrimmages?
I'd say one of the bigger takeaways is just make sure you're adaptable. So like some teams, we've practiced with them, they can only do specimens. While we prefer them, we were like, okay, yeah, we'll run samples. It's just to make sure that you guys can both work together, because trying to just be like the bigger boss, it's not always great.
Yeah, of course. Okay, now looking forward to the World Championship. Any things you want to talk about, or realizations you had from your last competitions that you're really looking on improving for Worlds?
Well, I've been working pretty hard on a level 3 hang that I'm pretty excited about, and then we've also been working on implementing the Limelight camera.
Very neat. All right, Open Source, thank you guys so much. I was really excited to talk to you. You guys have a fantastic robot this season. Best of luck in Houston. I'm sure you guys will do fantastic. So reporting for Fun Robotics Network, I'm Abhas, and this is Team 23213 Open Source. Thank you.